Our first standard is graph quadratics and identify characteristics. There's 4 objectives that will help us move along the scale in this standard. Those 4 objectives are first to be able to graph a quadratic that's given in standard form and identify the key points, including the axis of symmetry, the vertex, and 2 points on either side, which are usually the x and y intercepts. We need to be able to find the solutions to a quadratic by graphing. We need to be able to finish a partially filled in table for a quadratic function. And then finally, we need to be able to write a quadratic equation that has a given axis of symmetry and minimum and maximum value. Before we jump into graphing a quadratic, we need to do and know a little bit of background info. The first info that we need to know is that there are 2 forms that we will look at that a quadratic equation can come in. It can come in vertex form, which is a times x minus h squared plus k. And that looks very similar to our vertex form that we saw in a absolute value equation. H and k still give me my vertex. The a still tells me whether it's opening up or down and how wide or how narrow it will be. H is still the opposite sign of what it appears to be. The difference is that instead of it being a V shape, it will be a parabola or a U shape. Now, standard form has some great uses as well. Standard form is y equals ax squared plus bx plus c. It's the form that we will use when we are solving quadratics algebraically later in the chapter. It's also a form that will, just by looking at it, tell us what the y-intercept is, which is one of the key points you'll need to be able to identify. Both of these equations actually give me the same graph. One is just written in vertex form, and one is written in standard form. So let's actually look at what that graph would be for those equations and identify those key points on there that we'll have to identify later. The anatomy of our quadratic function kind of looks like this. It's a U shape, so we're going to make sure that we have a round bottom or a rounded top, not a V shape like what we had with absolute value. Other characteristics are listed on here, so you may want to pause the video to jot these down before we continue. The first characteristic that I like to find, regardless of what quadratic I'm graphing, is the vertex. Now, of course, if it's given in vertex form, it's really easy to find, but we're also going to learn how to use our calculator to find it later. The vertex gives me pieces of information for the other points that I need to include. The vertex y value will give me the minimum or maximum value. When it's opening up, that y value will serve as a minimum value. If it was opening down, the y value would serve as a maximum value. The vertex also gives me something called the axis of symmetry. You'll notice that a parabola is always symmetric. The points on either side can be mirrored across what's called an axis of symmetry. The axis of symmetry should always be written as an equation, x equals, and it's always the x coordinate of your vertex. We use a dotted line to graph it, and every parabola that you graph in this class needs to have an axis of symmetry, both labeled and graphed. Other key points to include would be the y-intercept. If it's given in standard form, your y-intercept is just the c value. And then the x-intercepts, or also called solutions, or zeros, or roots. Those are all referring to the same point or the same coordinates in the graph of a quadratic function. So when the standard asks us to identify at least 2 points on either side, one of those points, more often than not, will be your y-intercept. 2 of those points will serve from your x-intercepts. And then the other point can come from mirroring your y-intercept across the axis of symmetry. Now, it won't always work out that these will be on sides of your parabola. Occasionally, you might find that your y-intercept is also your vertex, and so therefore you'll need to find additional points, but we'll cover that in a moment when we look at our calculator and how to use it to be able to find our graph and our pieces for our quadratic. Much of the information that I shared just a moment ago is repeated down here. The vertex is also known as your max and min. It describes what your maximum and minimum is and how do you know if it's a maximum or minimum. And then here's where I wanted to remind you that solutions, roots, zeros, and x-intercepts, for purposes of this class, those words are all used interchangeably. So let's jump in to finding the solutions of a quadratic by graphing. Now, solutions can pop up in one of three ways. We could have a quadratic that has only one solution. So here's our coordinate plane, and if I had a quadratic that had only one solution, then it would go and touch the x-axis in only one location. And that would be my solution. Now in this case, that solution is also going to serve another key point. It's also going to be your vertex. That solution would also give me the value for your axis of symmetry equation. And we would need to find two other points on either side to complete our key points. In a situation where a parabola has two solutions, we would see the parabola either opening up or opening down. Any of these can open either way, but it would cross the x-axis in two locations, much like what we just saw when we were learning about the anatomy of that quadratic function. Finally, a parabola could have no solutions, and that would mean that when it is graphed, you would not be able to find a place where it crosses the x-axis. It will either be hanging up in the air or hanging down below the x-axis. We need to be able to actually list those solutions in just a moment. But first, let's actually go through and graph each of these quadratics. So we're given a quadratic here. It's given to us in standard form. And I know that because I don't have any set of parentheses and I have two x's here. It's in the form ax squared plus bx plus c, where this c value, if you remember, that c value tells me my y-intercept. So I can list my c value immediately. And I'll see if I can color code this for you. So we'll use pink for our y-intercept. I know that my y-intercept will be at 0, -3. My recommendation would be list out all the information that you can first before you go and graph this, because you may find that you need to change your scale in order to get all of your key points listed. Next, we need to find our axis of symmetry. Well, in order to find your axis of symmetry, you're going to have your vertex, because your vertex will go back to your axis of symmetry and it will give you your value for your minimum or maximum value. So you're going to need your calculator, because you may have noticed on the scale that we needed a calculator in order to graph these. So to graph, we'll go to y equals, clear out anything that's there, then type your equation in. So we'll use the xt theta n button for x. And then squared is actually right under the same button that we use to find the matrix. Or you can use the caret and 2, either way. But x squared plus 4x minus 3. The next step would be to actually take a look at it and see what it looks like. We can make sure that we have a standard negative 10 to 10 window by hitting zoom 6. And there's some things that we can tell just by looking at this graph. One is that it's going to have two solutions because it crosses the x-axis in two locations. It's going to have a minimum value because it is opening up. We can also tell that it's going to have a y-intercept that's serving as one of the 2 points that's listed on the side. So let's actually take a second to find as many points as we can using our calculator. Here, we'll put that underneath because it seems to be a little easier to read with it underneath. Starting with the vertex. Once we've identified whether it's a minimum or maximum value, we can press second and calc to find the vertex. So if I were you, I would jot that to the side. The vertex, we would press second and then calc. That was the trace button. And it said calc above it. Once you press that, you'll see that it says minimum and maximum. And you need to choose either 3 for minimum or 4 for maximum. We determined that ours was going to be a minimum because it was opening up. So we'll go down to 3. And it's asking us some questions. It's asking for the left bound, and in a moment it'll ask us for the right bound. What it's doing is it's searching for the minimum value, but you need to give it a place to start searching and a place to end searching, and it only knows how to move left to right. So you're going to move the cursor to the left side of where you know the minimum value can be found and press enter, and then move it to the right side of where you know your minimum value can be found and press enter. You'll see along the top 2 arrows. Those should always be pointing at each other, and your minimum value should be between them. Once you've confirmed that they're pointing at each other and the minimum is in between, you'll press enter one more time, and it will spit out your minimum. Occasionally, you'll see a minimum that has a bunch of zeros and then a number at the end, or you may have even seen one that has like E and then negative and a number at the end. You need to just be able to round this to a reasonable number. Remember, it's just searching, and it's doing the best that it can to find that minimum value. Something that's 2 with 3 or 4 or 5 zeros and then 1, we can safely assume that that really is at -2. Anytime you see a minimum or a maximum value, or you might see X or intercept or a 0 with E in it, you can safely assume that that would be 0. But we'll go ahead and copy down our vertex. It's at -2 and -7. Now that vertex, if you remember, gives us some important information. The x coordinate of it gives me my axis of symmetry, which is always written as an equation. X equals -2. The y coordinate of it will always give me my minimum or maximum value. And we already determined that it was a minimum value because it was opening up. So just finding one thing was able to find all sorts of other parts of this quadratic. We also need to be able to find the 2 points on either side. Well, since this quadratic has 2 solutions, or 2 places that it crosses the x-axis, those are going to serve as one of the points on either side. So to find those points, you will press second and then calc, and we'll select option 2. So we'll go ahead and write that down over to the side as our reference. We'll press second, and then the trace button, which says calc above it. And we select option 2, which is 0. And when you do that, it's going to spit out that same questioning sequence, left bound and right bound. So you need to already know that one of my x-intercepts is right here. So we'll need to move this cursor so that it's on the left side of that x-intercept. So it's on the left side, and we'll press enter. Then we're going to move the cursor so that it's on the right side of that x-intercept, and we'll press enter. Same check is going to happen. The arrows should be pointing at each other, and the point that you're trying to find should be between them. So we'll press enter one more time, and it will spit out one of our x-intercepts. Now, if you were looking on the other page, you would have seen that x-intercepts are also solutions. So we can go ahead and write these in as the solutions. And we'll round to the nearest hundredth. So that's 2 decimal places. And of course, we want to write them as points for the graph, but it's really the same number. When we refer to them as x-intercepts, we'll write them as points. When you refer to them as just solutions, you can write just x equals. Now, that's only one of our x-intercepts. So to find the other x-intercept, we have to go through this process again. Second, calc, option 2, and we're trying to find this x-intercept. So we want to move our cursor so that it's on the left side of that x-intercept, which it is. It doesn't matter how far left it is as long as we have moved it past the other x-intercept that we've already found. Move our cursor to the right side because now it's asking for the right bound. So it's on the right side of it. And we'll press enter to double check that our arrows are pointing at each other and that the 0 that I want to find is the only 0 that's between those 2 arrows. If you have both zeros between the arrows, then it will not necessarily give you this 0. You're giving it the option to give you the same 0 that you already found. So make sure that you only have 1 0 that happens between those arrows. And here's the next one. It's at 0.65. So the other x-intercept will be at 0.650. So now we have 1 point on either side from the x-intercepts, and we also have 1 point on the left side from the y-intercept. So our second point on the right side will come from actually graphing this and mirroring our y-intercept over the axis of symmetry. Now, we use a -10 to 10 window on our calculator, and that's what we're given on our paper, so we don't need to change our scale at all. So we're just going to start plotting these points. We have our y-intercept at 0, -3. Our axis of symmetry is at x equals -2. And remember, that's a dotted line. Our vertex is at -2, -7. And then we have our solutions at negative 4.65 and positive 0.65. Just estimate those as best you can. And so it's time for us to find that last point that's going to be our mirrored point. So the 2 points on either side that I haven't listed yet will be our mirrored point. The y-intercept is 2 away from the vertex, so if I continue to past, the axis of symmetry, if I continue to pass the axis of symmetry, I'll get my second point on the left side. And that's at negative 4, negative 3. So once you've plotted all of those points, it's time to connect the dots. And we want it to be a U shape. It should extend the entire graph, and it should go through all of our points. And these should all be listed over to the side. Now, in just doing this one graph, we've actually met kind of 2 of the objectives. We have graphed it in standard form, and we've listed the key points, and we've also learned how to find the solutions. Remember, when it's asking for solutions, we write it as x equals. When it's just asking us to graph it and find the x-intercepts, we write them as points. Now keep this for your reference as we work through the next few problems. So this is given to us in standard form, which means I can identify the y-intercept by just finding the c value, 0, negative 3. And then I'm going to type it into my calculator to find the vertex, which is kind of the key to unlocking half of the things that we need to find. So y equals, clear out what's there, and then type your equation in. 4x squared minus 6x minus 3. And we already know that we're dealing with a negative 10 to 10 window because we just graphed something in it, so we can go straight over to graph. Once again, I have a parabola that's opening up, which means I'm going to be dealing with a minimum value. So I can go and find the vertex by pressing second trace and going down to minimum. I know that the vertex is located right here, so my cursor is on the left side. Move my cursor to the right side. And I don't think I mentioned this before, but you could probably see it on the screen. I'm using the left and right arrow keys to move them. They're pointing at each other. My minimum value is between them. So we'll press enter one more time. And I have a vertex at 0.75 and negative 5.25. Now that vertex is important because it tells me 2 more pieces. It tells me my axis of symmetry. That comes from the x value. And we always write our axis of symmetry as x equals and then it also tells me what my minimum or maximum value is, which is negative 5.25 from the y value of your vertex. Next step would be to find the solutions. So we'll press second calc and go down to 0. One solution is right here. So I'm going to move my cursor to be on the left side of that point and press enter. I'll move my cursor to be on the right side of that point and press enter. It's pointing at each other and I have 1 0 in between it. So my x-intercept would be at negative 0.3, and that 9 is actually going to make it round up to be 0.4. Because the 5 will make the 9 round up, which will make the 3 round up. So that means that my solution will be at negative 0.4 or negative 0.4. Now we're going to go through the process to find this one. Second calc, option 2. We'll move our cursor so that it's past the first 0 that we found, but still on the left side. Press enter. Now the right side of that 0, and press enter. They're pointing at each other. There's one 0 in between it. So our next x-intercept will be at 1 point, and this 5 will make the 9 change, and that will also make the 8 change to a 9. So our other solution will be at 1.9. So I have 1 point on the right and 2 points on the left from the y-intercept and the solution. So if I mirror the y-intercept, I'll get my 4th point that I need, the second point that's on the right. Everything seems to fit on this graph, so I'm going to go ahead and plot my points. We have our y-intercept at 0, negative 3. Our vertex was at 0.75, negative 5.25. Just do your best with your estimating. Our x-intercepts were at negative 0.4 and 1.9. And our axis of symmetry, kind of skipped over that one by accident, goes right through x equals 0.75. Now your axis of symmetry should always move through your vertex. So I need one more point. I have my y-intercept that's 0.75 away from my axis of symmetry. So if I move 0.75 past my axis of symmetry to the point 1.5, comma, negative 3. So I've listed all of my points now. I can go ahead and connect my dots. The skinnier the parabola is, the more important it is for you to make sure that you have a nice rounded bottom or rounded top to your parabola so that I know that you know what the shape is supposed to be. Let's move on to number 3. The y-intercept is listed at 0, 4 because it's in standard form. I can just list what's ever there. I'm going to type this into my calculator to take a look at the graph. So clear out what's there. We're going to y equals, and we'll type negative x to the second power minus 3x plus 4. So we'll take a look and see what it looks like on this negative 10 to 10 window. Looks like it fits pretty well. Now this time we have a parabola that's opening down, which means that we will be dealing with a maximum value this time. So when I go to find the vertex, I will press second calc, and this time I'll select option 4, maximum. So we need to move our cursor to the left side of the highest point, the right side of the highest point. Double check that your arrows are pointing at each other and your maximum is in between. And we found a maximum at negative 1.5 and positive 6.25. That's our vertex. That tells us my axis of symmetry is at x equals, please don't forget that part, An axis indicates a line, so your equation is important. Don't just tell me negative 1.5. And then it also tells me what my maximum value is, 6.25. I have two solutions. So second calc, option 2. We'll move our cursor over. We'll find our left solution first. So here's my solution, or my x-intercept. I'll move my cursor to the left side and press enter. Move it to the right side and press enter. Arrows are pointing at each other. My point that I'm trying to find is the only one that's between it. So enter one more time gives me a solution, this time at x equals -4, or as the x-intercept would be -4, comma, and here's what I was talking about with that e. It's really just 0. What that e is its scientific notation saying that there's 11 zeros in front of that 1. I think we can safely assume that that would just be counted as 0. So we'll have second calc, option 2 to find this one. So move the cursor past that 0, so it's on the left side. Whoopsie. It's on the left side, so we'll press enter. Move it to the right side, which means you'll have to pass it, and press enter. And enter one more time once you've verified those points. And we have a 0 at 1, 0, which means that my solution will be at 1. Let's go ahead and plot the points. Our y-intercept is at 4. Our vertex is at -1.5 and 6.25. Our axis of symmetry goes down through -1.25, right through our vertex just as it's intended. And then our solutions, one is at -4, and one is at +1. And the final point to make up the 2 on either side, we know that it's 1.5 away from the axis of symmetry, so we'll move 1.5 past it. And that point is at 3, 4. -3, 4. We're going to do 2 more, but this time they'll be in vertex form. It'll just give us a little bit more practice finding those points and hopefully help you make the connection between writing an equation with an axis of symmetry and a minimum and maximum value for your standard or your objective for tomorrow. So when it's written in vertex form, there'll only be one x value, there'll be parentheses raised to a power. Remember that vertex form is y equals a x minus h squared plus k. So we can identify the vertex straight from looking at our equation. So our vertex in this case would be hk. H is always the opposite of what it appears to be. So h in this case would be 2, and k is the same sign of what it appears to be, -4. So our hk would be 2, -4. Just like before, I can tell the same things from the vertex. I can tell my axis of symmetry, and I can tell my minimum or maximum value. Now, technically speaking, you should be able to tell whether it's a minimum or maximum without looking at the graph, because when it is a positive A value, and this is true even in standard form. It'll be opening up. When it's a negative A value, it'll be opening down. So minimum value when it opens up, maximum when it opens down. But you can always use your calculator to find it. So we'll start now putting this into our calculator. Clear out what's there. 3 parentheses x minus 2, close your parentheses, squared minus 4. So we'll go ahead and graph that. And we could calculate out our vertex again, but we just found it. We do, however, need to find our y-intercept and our solutions. So we'll go ahead and find our solutions by pressing second, calc option 2. The first one, we need to make sure that the cursor is on the left side of it, and it is. Then we'll move the cursor to the right side. The arrows are pointing at each other, and my 0 is at 0.85, comma 0. And then we'll find the other one, second calc option 2, move it past my left 0 and press enter, to the right side of the 0 and press enter. And we have a 0 at 3.150. So my solutions are at 0.85 and 3.15. We have not found the y-intercept, and there's a couple of ways that you can do that. You can put 0 in here and solve this out to find the y-intercept, or you can look at your table. So second table, and move your cursor to where the x is 0, because that will be what your y-intercept is. Remember, our y-intercept is always 0 comma something. So 0 comma 8 is our y-intercept. Now the table can also be the location where you find other points when your y-intercept and your x-intercepts are also part of the vertex. So you can go to your vertex and find some points on either side. Now we know from looking at this that that vertex is acting as our minimum value. So we're ready to graph. So we have our y-intercept at 0, 8. Our vertex is at 2, negative 4. Our x-intercepts are at 0.85 and again at 3.15. And with the decimals, you just need to estimate as close as you can get. Our axis of symmetry goes straight up through x equals 2. And to find that last symmetrical point to make up the 2 on either side, we will move 2 past the axis of symmetry from our y-intercept. And that point is at 4, 8. Make sure that we have a rounded part for our minimum and draw our line. Last one. Since it's in vertex form, I can identify the vertex just from my h and my k value. H is the opposite of what it appears to be, so it's at negative 1. K is at 3, so my vertex is at negative 1, 3. That means that my axis of symmetry will be at x equals negative 1, and my minimum value or my maximum value would be at 3. Now again, Since this is negative, we know it'll be opening down, so it will serve as a maximum value, but you can wait to do that until you've seen what it looks like on the graph. So y equals, clear out what's there, -2 parentheses x plus 1 squared plus 3 graph. So it is opening down, confirming what we thought. It is a maximum value. And we need to find the zeros. So second calc, option 2. For the left 0, we'll move our cursor to the left side of the 0 and then pass it so that we're on the right side of the 0. Arrows are pointing at each other with the 0 in the middle. And one of my zeros will be at -2.220. And then the second one, second calc, option 2, move past that left 0 that we had onto the left side, move to the right side of the second 0, and we get the second 0 happening at 0.220. So that means our solutions will be at x equals -2.22 and 0.22. Our y-intercept can be found from our graph or better yet, our table. So x equals 0 means that y is at 1. So let's go ahead and plot our points. Y-intercept is at 0, 1. Vertex, -1 and 3. Axis of symmetry, x equals -1. Our x-intercepts are at -2.22 and 0.22. And then we need that last point mirrored. Our y-intercept was 1 away from the axis of symmetry, so continue 1 past it. And then connect your dots.